Okay, let's close out our unit by talking about the four fundamental forces. Pretty much the most important stuff in the universe. No exaggeration. Four fundamental forces are how particles interact with each other. So that's why I'm talking about as the most important stuff in the universe. It all comes down to these four things, and you don't need to write these down quite yet. We'll write them down in just a second. The electromagnetic force, the strong nuclear, the weak nuclear, and gravitational, or gravity. First one, electromagnetic. Electromagnetic is forces that occur between charged particles. So this is where you have positives and negatives. And if you have two positives, those are going to repel. If you have two negatives, those are going to repel. But if you have a positive and a negative, an opposite, those are actually going to attract. Positives are going to repel, negatives are going to repel, positive and negative will attract. Opposites attract. Here you can kind of see an example of the magnetic fields, and those are two very, very powerful magnets there. If your hand was between those, you might actually lose your hand. Those things are pretty powerful and not at all easy to get apart. Those magnetic fields are invisible to the naked eye, but these are opposite charges, essentially. With magnetism, they're kind of the same thing. Very, very strongly attracted to one another. Now let's talk about the strong and the weak nuclear. Now I'm kind of combining these together because I'm not asking you to split the difference or to try to tell the difference. For now, all you need to know is that these are the forces that hold atoms together. And if you break them, a lot of energy is released. This right here is uranium-235. If uranium-235 is hit with a neutron, it temporarily becomes uranium-236, which is unstable and will split into krypton and barium, along with three other neutrons, and this yellow stuff is energy. A lot of energy. This is the basis behind nuclear weapons and nuclear reactors. One splits, causes others to split. Each one of those releasing energy in a chain reaction. This is the basis for how our nuclear reactors work. And it's, how to put it, a lot of energy. This is an atmospheric test of probably a hydrogen bond, which is both the strong and the weak nuclear. But there you can kind of get an idea. Yeah, it's powerful. When you break the forces that hold atoms together, a lot of energy is released. Here you can kind of see a couple miles away from the blast zone what this actually just does to the surrounding environments. It's a lot. And finally, the last one is gravitational, or gravity. This is an attractive force between any two masses. Literally anything with mass will have a gravitational force. Here I have one mass here and one mass here, X and Y. They're going to be attracted to each other. Right here, I'm going to have more attraction. You'll see the arrows are bigger because I have more mass. Here, I have less attraction, not because they're smaller, but because it has a lot to do with their distance. So the closer they are, or the more massive one of them is, the stronger the attraction is. So the force depends upon the mass and the distance between those objects. This is the weakest and this is the weirdest of the fundamental forces.